Hi, Math 1050. This is section 7.1. We'll be learning about ellipse. So ellipses are kind of closely related to circles. They're both conic sections. So I want to show you a graph of a circle and a graph of an ellipse so that we can kind of talk about how they're similar and how they're different. So you are very familiar with circles. So I might have a circle with a center at 4, 1. And maybe it has a radius of 3. And so my circle might look something like, you know what? I've got technology, I might as well use it. So my circle might look something like this. And you know that the equation of that circle would probably be written as x minus 4 squared plus y minus 1 squared is equal to 9. And the number here at the end of the equation is the radius squared. Well, an ellipse might also be centered somewhere like 4, 1. And if an ellipse was centered at 4, 1, you would also see an x minus 4 squared, and you would see a y minus 1 squared in its equation, and they would still be added together. For a standard form ellipse equation, it's always going to be equal to 1, and you're going to see some denominators. And so let's see, if our ellipse had, maybe our ellipse is 4 in one direction and 2 in the other. Maybe our ellipse looks something like this, an elongated circle. In that case, you would see a 16 denominator here, and you would see a 4 denominator here, where this is what we call our major axis squared. So in this case, 4 squared. And this would be our minor axis squared, which is 2 squared, which gives me 4. So this would be an A and a B. So instead of having those two distances the same, for an ellipse, there are two different numbers. And you can think of a circle equation this way too. If you want, we would just divide everything by 9. And so then we would have x minus 4 squared over 9 equals plus y minus 1 squared over 9 is equal to 1. So a circle is really like a special case of an ellipse, almost. We're going to graph a couple of ellipses, and then we'll talk more about like what the exact definition of an ellipse is and do a couple other topics. So starting with graphing though, here's our equation right here. So in Alex, to graph it, you will just mark where your center is. So this is -2 and -3. And then you'll count out your major and minor axes. So in the x direction, we're going to count out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then in the y direction, we're going to count out 4. 1, 2, 3, 4. 1, 2, 3, 4. Wonder how this works. Okay, let's see if I can get it. Nope, I am gonna fail miserably at that. But I'm so bad at drawing shapes on my tablet. Nope. Guess I should have just drawn it, huh? There we go, sort of. Okay, so Alex is going to draw that ellipse for you automatically once you plot those points. So, hey, not bad. Okay, so that's how you would plot it. Now, some of your ellipse may look like this equation. And this equation sometimes throws people for a loop. It is in standard form. It is equal to 1 right now. The center is relatively easy to find. The center is at 2, -3. And a lot of people are like, okay, I can count out 4 in the y direction. 1, 2, 3, 4, 1, 2, 3, 4, but the x direction gives them a little trouble. You need to realize that that denominator would be a 1, and 1 squared is 1, so we're going to count in each direction by 1. So this one is a very skinny, sort of elongated ellipse. I'm going to do my best to draw it. Oh, geez. I'm just so bad at drawing these on my tablet. I do a lot better on the board in class. So we have a minor axis of 1 in the x direction, and we have a major axis. Wow, I'm good at spelling. Major axis of 4, and that is in the y direction. Okay, so let's talk a little bit more about like the definition of an ellipse. Like the superficial definition of a circle is that it's the collection or the set of all points on a plane such that the distance from the center is always constant or is the same, and that distance is called the radius. Well, an ellipse is the set of all points in a plane such that the sum of the distances from 2 fixed points is constant. The 2 fixed points are called the foci. And so I have a diagram here of an ellipse. It has a foci of A and a foci of B. And every point on the edge of this ellipse has the same sum of the distance from A and the distance of B. So you can see as I move it around, my A right now is 2.67, my B is 3.8. That adds up to 6.47. And if I move that point around, it always adds up to 6.47 for this particular ellipse. So as A is getting shorter, B is getting longer. As B is getting longer, A is getting shorter, but always their sum is the same. And if you change the size of the ellipse, like if I make the ellipse bigger or smaller, that distance is different for each ellipse. So for a big ellipse, that distance at A plus B might be 8.6. But for that particular ellipse, once I have it set up, the distance A plus B is constant. Okay, so the next topic in Alex is going to give you an equation for an ellipse, and it's going to ask you for 5 points. So the 5 points it wants are the center, because every ellipse has a center. So it's going to ask you for the center. It's going to ask you for the location of the 2 foci. And then it's going to ask you for these 2 points, which we call the vertices. The other 2 points that sometimes come up are these 2. They're called the covertices, but we will not need to calculate them for this next topic. We will just be looking for these 5 points, the vertices, so plural vertex, the foci, and the center. So I have included a little note sheet that kind of shows you those and has little formulas here, but I think it's very useful to actually just refer to the formula sheet that you have, because you're going to have that available to you when you take your tests. So it gives you the standard form of an ellipse on your formula sheet. It tells you that the major axis is horizontal or vertical, depending on which of these numbers is larger. And then it tells you about the foci. So this is what we're going to use. The foci are C units away from the center along the major axis, where C squared is equal to A squared minus B squared. It has absolute value here because if B is greater than A or A is greater than B, you just want to find that distance between the 2 squares. Okay, so here's our equation. So first of all, finding the center, very easy. It's going to be at 6, -1 for this equation. Now, to find the vertices, I think the best way to do it is to kind of sketch your ellipse. And you don't need to like sketch your whole coordinate plane because some of these may have centers, way off to the side one way or the other. I just start with that point that is the center 6, -1. And so in our x direction, we're going to be counting out 3. And in our y direction, we're going to be counting out 5. Okay, so here is our rough sketch of our ellipse. Okay, so the 5 points that we need to find are the center, which we already found. We need to find these vertices, which we can now write the location of those vertices. So the x coordinate is going to be the same, right? For this ellipse, at least, because its major axis, its longer axis is in the y direction. So those all have the same x coordinate of 6. We need to figure out their y coordinate. Well, we got here by counting 5 down. So that's going to be at 6, -6, because it started at -1. And then we got to this point by counting 5 up. So 5 above -1 is 4. So we have now found our 2 vertices. And again, I just used the y coordinate of the center and I subtracted 5. I used the y coordinate of the center and I added 5. Whoops, I put a comma. But I definitely don't need a comma there. Okay, so the other 2 points that we want are the foci. Now, the foci are going to be, somewhere here. And so we need to calculate how far above and below the center they are. And so we'll use this equation. They're c units away from the center, where c squared is equal to a squared minus b squared, absolute value. I just like to do the larger one minus the smaller one. Now, if you're looking at your equation, remember this is like an a squared and a b squared. So they are already squared if you're looking in the equation. Or if you're looking at your shape, then you do want to square it. So 5 squared is 25 and 3 squared is 9. So whichever is the easier place for you to sort of see what you need to see. So c squared is 16, and that means our c value is 4. So the focus is 4 below and 4 above the center. So that puts this lower focus at 6, -5. And that puts this upper focus at 6, 3. So that 3 comes from -1 plus 4. When you're doing this topic, please be sure to pay attention to whether your major axis is vertical or horizontal. It could give you an equation like this, where if you find your location of your center, let's just call this -2, 1. In this case, we would be counting out 4 in the x direction to get those vertices. So this would be, sometimes I think having a coordinate plane makes it harder to visualize. Let's see, I mean a grid, an axis, sorry. Okay, so if we think about our vertices here, I went back 4, so that would put one of them at -6, 1, and that would put this at 2, 1, because I'm adding 4 in the x direction. And because the y direction is only 1. So this one, the major axis is horizontal, and so our points are going to be in a horizontal line, all with the same y value. So for this one, our center would be -2, 1. Our vertices would be at -6, 1, and 2, 1. And then we need to find our foci. The foci, we have to do 16 minus 1. So that's our a squared minus b squared, and that's c squared. So in this case, c squared is 15, so c is root 15. So you may have to type in a root as part of your response. So this would be, they would have a height of 1 because they're all along that line, that horizontal line. So it would be a -2 plus root 15 and a -2 minus root 15. And we couldn't really simplify those two anymore. So it could be the case that you'll have a root come up in one of your problems. And then just pay attention to whether your major axis is horizontal or vertical. Okay, so then you'll also have a couple of word problems involving ellipse. The first thing that you want to do is set up your equation. So this one says that we've got an arched sort of bridge that tunnel under the bridge, I guess, and it's a semi-ellipse, so it's half of an ellipse. And the arch itself is 164 meters long, and it has a height of 52 at the center. We have a point P that is located 11 meters away from the center, and we want to find the arch height above point P. So the first thing you want to do is set up your equation. So it's going to be set up in standard form like this. Now, when we set these equations up, we are going to take that center to be the origin, which is kind of just going to simplify our equations just like this. So we have x squared over, in the x direction, our major axis length is going to be half of that whole ellipse, so it's going to be 82. And don't forget that that's squared. And then plus y squared over, and the height right here, that minor axis is 52. Don't forget to square it. I know these are huge numbers, but don't forget to square them, and that's equal to 1. Now, the point, or the distance that we're trying to find here is an x value. We're trying to figure out, a y value. We're trying to figure out how high that is. And if you think about this point on the edge, it has an x coordinate of 11 and a y coordinate of we don't know. That's what we're trying to figure out. So we're going to be solving for y when x equals 11. And that's because our point is 11 something. So, you can solve this equation however you make sense to you for getting y by itself. If you like to maybe work algebraically for a minute, you can. If you prefer to put these numbers into your calculator so that you're not dealing with powers, you can. It just depends on what you like. I'm going to do it without punching anything into my calculator until very, very last. So I'm going to subtract this. Which leaves me with y squared over 52 squared is equal to 1 minus 11 squared over 82 squared. And then I'll just multiply both sides by 52 squared. So that gives me y squared. So I'm going to use my calculator to evaluate this. And that's easy enough to type into your calculator. Make sure you group it in the way that will keep your answer correct. Watch out, for sort of typos that make your answer wrong. So 1 minus 11 squared over 82 squared times 52 squared gives me a nice decimally number, and that's fine. That is not your answer. And I hope, logically, you can realize that that is not the right answer looking at your diagram. It's asking us for the height. It definitely can't be more than 52. This is y squared. So do not forget your last step is to take the square root. And so we get y is equal to 51 point, and it asked me to round to the nearest hundredth, so 51.53 meters. And that really makes sense on my diagram. It's not too much lower than the height at the center. I want to try one more setup there because this one is slightly different. This time, it still gives us the information about the bridge, or some of them are like a floor mat or something, but they all work the same. This one gives me that the height is 19 meters, and it wants to know how far away from the center that's occurring horizontally. So if we, again, start by setting up your equation. And remember that the center is the origin. So setting up the equation is a little simpler when the center is the origin. So this would be x squared over, and I have to use half of that 168. So that would be 84. And then that is squared, plus y squared, since the center is the origin, over 62 squared is equal to 1. So that's our equation for this ellipse. Now we're going to solve. The point that we're interested in, or the number we're interested in, is this distance here. So if I think about this point on the edge of the circle, that occurs at, we don't know which x value, but the y value is 19. So we're going to solve for x when y is equal to 19, because the point, I guess, that's involved in this problem is a height of 19. So if we substitute 19 in for y, and then we're going to solve for x, just like before, I would go ahead and subtract this amount. So now we have x squared over 84 squared is equal to 1 minus 19 squared over 62 squared. And then I can multiply both sides of my equation by 84 squared. We'll throw that into the calculator. And don't forget, when you get your answer to this little calculation, you're not finished. That tells you that x squared is equal to 6,393.3527. I would not round on this step. I would not round until the very end. And again, that number just came from the calculator. And then don't forget to take your square root of both sides. So the x value that we're looking for is 79.96. I would make sure that that makes sense in the context of your problem. We're definitely looking for a number less than 84. I would not assume the diagram is to scale. So really, to get a height of 19, you're way farther over here. So the 79.96 makes sense to me. All right, so that's it for 7.1. Let me know what homework questions you're having trouble with. Thank you so much.